Thanks so much for coming to the first Osterbrock Leadership Lecture. I'm Paul Koch. I'm the Dean of Physical and Biological Sciences. And my main job is to introduce Sandy Faber, distinguished astronomer, professor emeritus here at UC Santa Cruz. I'm actually not going to run through Sandy's many prizes and awards. The thing I wanted to focus on actually is what this leadership talk is about. It's a prize that recognizes Donald and Irene Osterbrock, and the idea that we were going to honor leadership, that we were going to focus on the skills, in particularly graduate students and postdocs, that faculty members or citizens need, but in this case, focusing it on graduate students. I believe that came from a conversation that Sandy had with Irene. I'm not sure where that idea came from, but I really want to recognize the wisdom of that, of having a prize that focuses not just on grad support, which is great, but on the other things that graduate students need, the other skills they need. The department's been really, the astronomy department in particular has been very proactive, very active in the kinds of training it gives its grad students. I'm very impressed with the teacher training that you do, and that's really important. Some of you are going to be teachers, some of you are going to be professors, but not all of you are going to be professors. Not all of you want to be professors. And the other kinds of skills you need, the skills to lead a large project, the skills to do things outside of academia, those are absolutely important, and many grad programs don't ensure that you have those skills. So I'm really, really happy to introduce Sandy Faber, who conceived of this.
Thank you, Paul, for hosting us today and for that lovely introduction. You've already said several of the things that I wanted to say, but that permits me to expand. Being a professor, that's something I like to do. So, as Paul notes, PhDs are major investments by the trainee, the PhD student, but also by society at large. And those costs are paid for mostly by taxpayers. And at one point I did a little accounting for what I thought an astronomy PhD cost. Don't listen to this. $500,000. And so that is a heck of a wad of cash. And it would be nice to think that we're creating people who can be maximally effective, given that we've invested in them at that level. So thinking a little bit further about what the typical PhD does, it trains people to do research, and I think that's wonderful because that really cultivates creativity and analytical thinking, which we need more of in society. But on moments more reflection, said that many astronomy students are, and I'm sure in all PhDs, are going on to scientific leadership positions. Let me give you just 3 examples from astronomy. Our former dean, Steve Thorsett, is now president of Willamette University. Franz Cordova was chancellor of UC Riverside, president of Purdue, and is now head of the National Science Foundation. And our own George Blumenthal, of course, started out as an astronomer here and is now chancellor of this campus. And I just guarantee that none of those people had any inkling as graduate students that they were going to wind up in those positions. And even if you don't think at that level, nevertheless, as Paul will attest, just being dean or department chair or leading a large scientific project or even leading your lab if you're a biological scientist or a lab scientist, somehow leadership doesn't get any easier just because the organization is smaller. So I suspect that many of you science PhDs and even undergraduates and masters are going to be challenged with leadership experiences in the future. So, as Paul explained, the Osterbrock program is designed to fill that gap by augmenting a very fine and rigorous PhD research training with exposure to special leadership events and experiences, including introductions and personal relationships with great leaders from the outside world. The program is named after Don Osterbrock, who was an eminent astronomer here at UCSC and also a great leader. He was director of the observatory at the time when the University of California went into the Keck telescopes, which twin 10-meter telescopes a very ambitious project for the time. And Don was leading us during that critical period. I also want to acknowledge his wife, Irene, who was also a leader in her own way. She played a major role in expanding something called the Shane Archives, which are the archives of Lick Observatory, and they're housed in our library here, and they are one of 2 or 3 great archival sites for astronomy in the entire world. And we're very, very sorry that Irene could not be with us today. She's with us in her thoughts. In addition to being a great role model for this program, she's also a great supporter of it, and we owe her a great debt. Well, now let me turn to the lecture. It's supposed to be an annual event. This would be the first inaugural lecture. It's aimed, as I've said, at students who are earning science degrees. The point is to invite the entire campus and thus broaden the impact of the Osterbrock program beyond just astronomy. And the goal is to bring distinguished leaders from all parts of society to share their leadership experiences with the goal of stimulating and assisting you students in thinking about the part that leadership might play in your own future careers. So now, with all of that said, let me give you a portrait of our wonderful speaker today, Robert Kirshner. Bob is eminently qualified to kick off this lectureship series, as he is widely recognized as one of the most influential thought leaders in astronomy today. So I learned a little bit more about you for the purpose of this introduction. All good. He was an undergraduate at Harvard, and I learned that you won the Bowden Prize for Useful and Polite Literature while an undergraduate at Harvard, and I'd say you've been trying hard ever since to live up to that early recognition with considerable success. I'd say you are a pretty polite guy, Bob. He went on to Caltech for a PhD, was a professor at Harvard for 30 years, and now has come out here to head the Office of Science Programs at the Gordon and Betty Moore Foundation, which obviously is a very important leadership position in science. And in fact, you know, most of science leadership is rather diffuse, but by virtue of your position in this foundation, you arguably are maybe the single most important individual in science. No,
Tell me more, I'm fascinated.
I am not exaggerating. That almost anyone can think of. Maybe you could think of other people, but I can't. What about Bob's research? Well, I'm sure that many of you have heard about one of the most astounding discoveries in astronomy recently. That is the fact that the universe is accelerating rather than slowing down. And this requires negative or repulsive gravity, which can only be generated by some mysterious entity, which we've, with great insight, named dark energy, because we know so much about it. Obviously, we don't know anything about it. In my humble opinion, dark energy is the most important discovery in all of physics and astronomy for the last half century. Now, how does such a momentous discovery come about? Well, the answer is that you have to have a precision ruler for measuring distances very accurately to galaxies that are billions of light years away. And it was Bob and his students and team who were responsible for calibrating type 1a supernova as that tool. 2 of his PhD students shared the Nobel Prize. One of them, Brian Schmidt, said of Bob Kirshner, more than anyone, shaped me as an astronomer. His team as a whole shared the Gruber and Breakthrough Prizes, and Bob himself recently shared the Wolf Prize in Physics with the citation, hang on here, achievements in the interests of mankind and friendly relations among people.
Useful and polite.
Exactly. So, Bob, you've anticipated my next thought. I think you're the only astronomer I know who has received not 1 but 2 prizes for being polite.
Thank you.
Congratulations.
Well, try not to
Now,
interrupt.
what I haven't told you up to now is that Bob is also renowned and revered as one of the most entertaining and rewarding speakers in the entire astronomy pantheon, and his humor and insights I would say are legendary. So I invite you to sit back, buckle your seatbelts, and enjoy Bob's talk entitled Science in a Time of Accelerating Turbulence. Go to it, Bob.
Thank you. Whoa. Oh, after that introduction, I can hardly wait to hear myself. This is really going to be something, I'm sure. Well, so as Sandy said, I have been at Harvard for 30 years as a professor of astronomy. Before that, I was at the University of Michigan. And I have recently come to California to work at the Gordon and Betty Moore Foundation, where I'm in charge of the science program. And I have discovered that since arriving, I'm much more popular. When I was somebody who was begging for money, I was okay, but now I'm something else. All right. And I show you here an image of the supernova 1987A. That's part of my story for today. So this is the first annual Osterbrock lecture, and I guess I'll be coming back every year to do this. And so I'll try to make some progress in the next 11 months. But just to say a few words about Don Osterbrock, who is someone I really knew. Not closely, I didn't work with him precisely, but I knew him as the director of the observatory here, and especially as a leader in thinking based on evidence, a topic to which I will return, because that is such a rare thing in the public discourse today. Thinking based on evidence, in his case, astronomical evidence about what astrophysical gases were doing, but also a wise person who helped guide the University of California toward the big telescopes that Sandy mentioned a minute ago. There was a very lively discussion about which way to go, whether the mirror for the 10-meter telescope was going to be a single meniscus, a solid mirror, or whether it would be the segmented mirror that people eventually went to. And it was a very contentious activity, which Don presided over with grace and a good outcome for all in the end. Sandy alluded to the fact that this is partly about what kind of person becomes a grad. Well, first let me say a word about Don coming to California, because now I've done it too. What I find is we moved all our household goods out to near Palo Alto, and I have not been able to find my snow shovel, but I haven't needed it, so that's been a good thing. Let me just say, I looked in the newspaper this morning. You know, they have this thing where they print out the contents of the website, and I found this most apt thing. It says the best place to be in California is Santa Cruz. And I guess Don Osterbrock got the message in 1973 and came out here to be the director after a long, happy years in Wisconsin. He was a Midwesterner. His wife was from Wisconsin, and they were happy there, but they were happy here too. So I have this picture that shows some of the present members of the faculty and some who are gone, but Don Osterbrock is here. George Blumenthal was referred to a little while ago. You know, he had a career as an astronomer before he was a distinguished academic leader, and there he is back there in blue. And some of the other people are in the room, so you can identify them. I always thought of the Santa Cruz and the Lick Observatory as a place where that would be like heaven to be there. There was a terrific research group, and it is a wonderful, lively intellectual setting. So I thought I would just pay attention to this issue of sort of who, you know, this is supposed to be something about faculty mentoring students over a wide range of activities. But the main activity, of course, is getting your PhD if you're a graduate student in astronomy. And this is a list that I was able to construct. I don't know if it's complete. There are probably people here who can help me. But this is a list of Donna Osterbrock students. And it's an extraordinary list. As Sandy mentioned, it turns out that life takes different turns, and sometimes people become things that they were not headed toward. Bob Williams, of course, became the director at the Space Telescope Science Institute after a long career at the University of Arizona. George Abell is a legendary figure in reaching back really a whole generation before into the dawn of extragalactic astronomy. Well, anyway, it's a long list, and it's just to say that the combination of Don Osterbrock's own scientific program, where he enlisted these students and then helped them grow into real actors in the field, is something that has populated, this action has populated astronomy, and there are a lot of people out there. There's Joe Muller, who came back to Santa Cruz, who are really the beneficiaries of Don's generosity. And it's part of the fun of being a faculty member for a long time, is that your students are out there doing all these great things. I want to tell you a little bit about one of his students. Well, here's a picture of Don. I think he was probably about 50 then. Here's Alan Koski, who's someone I hired when I was at Michigan. And Mark Phillips is standing there in the background. And I wanted to bring up Mark Phillips, who was a really good student and would have been an excellent person studying active galactic nuclei, Greg. But he was knocked off this course in 1987. And I want to say a word about what did that to Mark Phillips. And it was Supernova 1987A. It was the first supernova found in 1987. It wasn't found until late in February. So today, the first supernova would be found. Many supernovae are found each day, and the whole field has perked up quite a bit. 87A helped propel a lot of us, Stan, on our path. But for Mark, who was then working at Local Observatory, the supernova was in the Large Magellanic Cloud, a southern constellation, not visible from northern latitudes. And the discovery in Chile led him to put all his time and all his energy into studying that supernova and then other supernovae later. So how many people here were born after 1987? Pretty good fraction, so you can be excused for not remembering this. Everything I say will be new, true, useful, and polite. Okay. So let's have a look at what people thought when this supernova was discovered. Let's see if this works. Oh boy. Are you ready? Here we go.
Tonight on Nova, Supernova. A star blows itself apart in the most violent event in the universe.
It's just a great thing. You sort of hope all your life, really, that you're going to get to see something like this.
Well, I almost fell over. I remember walking around for about a week, and everyone I would see, I'd say, boom!
Astronomers the world over scramble to uncover the mystery behind the death of a star.
Well, don't we ever try to understand the death of a star. This was a Nova show that was made as the work on the supernova was progressing. And so as a result, they were able to go to the American Physical Society meeting, and the supernova occurred in February. The American Physical Society meeting, they used to have a thing they called the April meeting. This year, the April meeting was held in January. But in 1987, it was held in April. I don't know why they call it that. And by that time, this February discovery had resulted in some interesting work, including me not quite accurately identifying which star had exploded. And so I want to show you a little clip. This is from the American Physical. I showed this at the American Physical Society meeting in January. This is sort of the meta story. Anyway, and this is a recording, and this is real stuff that they did at the meeting in 1987. So let's just play this.
2 months later in Washington, D.C., a distinguished group of physicists gathered to celebrate the success.
The fact that we can understand is just absolutely out of sight. I mean, the notion that we can really understand these things, I can't believe it, because, damn it, I mean, this whole house of cards gets built up,
Present were Sterling Colgate, Nobel Prize winner Willie Fowler, and Fred Reines, whose American-based collaboration also detected neutrinos from the supernova.
We have a chance to do some experimental observational work and check up on all the theories that they've done.
Wait till we get one of these galaxies.
Oh, this is close enough for me.
See that guy? Those neutrinos go chunk to chunk to chunk.
Neutrinos were not the sole topic of conversation. There were rumors that Bob Kirshner had finally changed his mind about the progenitor star.
No, I think Kirshner's kind of caved on Santa
Arguing about this, you're saying that the original statement that it was this Santa Cruz star
It was retracted.
and now it's back.
And now it's back again.
He gets it gone, and that he likes it B minus 69,202.
Say again?
Kirshner vision. I think he's going to say that tonight.
Well, it's a great pleasure to see so many familiar and especially to see so many unfamiliar faces. That is to say, I think that the observations that we've seen over the last month of this very interesting object have brought together a very wide group of people who ordinarily pass one another in halls with polite grunts at best.
Supernova 1987A has some special features. I think all of those special features, or most of them, can be accounted for by the hypothesis that the supernova really did come from the Sanduic minus 69202 star, that it's the one that blew up. It's massive, so we expect to form a neutron star. So I think, and most importantly, down in red, the star is now absent. So it seems to me, in a positive sense, this would have all the right characteristics, and the fact that it's not there makes it a plausible case, I think, that the Sanduic star is the one that blew up and became the supernova 1987A.
Okay, so one thing is science, it's really good to be right. Not so good to be wrong, and that was a time when I was wrong for a while. So I just want to be clear about this in case there's any question, because you've been working on identifying progenitors and so on. Here's my rule for this. Hi, there you are. You have been working to identify progenitors. You cannot identify a supernova progenitor by position alone. If it's in the same place as as a previous star, that doesn't mean it did it. You need to show that the candidate is absent when the supernova fades, a lesson I learned 30 years ago and will not forget. Okay, so this is about Supernova 1987A knocking Mark Phillips off his course. But I also wanted to say 87A, that was 30 years ago, and a lot of good things have happened in the last 30 years that allow us to have instrumentation which is much more powerful than what we had in 1987. In 1987, the Space Telescope was the International Ultraviolet Explorer, a very small, rather limited instrument. And although there was a request for proposals to use the Hubble Space Telescope in 1986, to which I responded, the actual launch of the Space Telescope wasn't until 1990. And I show you here the Space Telescope. I don't know who took this picture. As you know, when it was first put into action, it was very disappointing because the mirror had been figured very precisely to the wrong shape. And so as a result, the images were not so good. Nevertheless, for 87A, which was one of the early targets, we got this surprising image where the blob in the middle is the shredded star expanding after the explosion, but it had a ring around it. Now, in fact, we had some clue that there was something in the neighborhood from the IU. We didn't have an image like this. We had fluorescence, light that was the result of the explosion that we could measure and that we noticed took 400 days to get to its maximum brightness. And we thought, well, gee, what could do that? It would be a sphere around the star so that it had with a radius of 200 days. So the light that was going to the farthest part of the sphere would take 200 days to get there, and then it would take 200 days to get back, and after 400 days you'd be seeing this whole sphere. That's, of course, the Pythagorean view. You know, if you only know one thing, you think of the most perfect thing that has only one number to describe it. That would be a sphere. But it's not a sphere, as you can see here. It's a ring. It was in a plane. It looks elliptical, but it's nearly a circular ring tipped to our line of sight. So what's the lesson from that? Well, two lessons. One was that even before the Space Telescope was refurbished, repaired, and made to work properly, that it was possible to do some science. And the other, kind of more important, is that our original idea was too simple, and that nature did something that was more complicated than we had thought. And we think now that this planar ring, which I'll show you again in some of the later images, is something which was the result of two stars swirling around each other, and that gas is related to the evolution of the stars and gas that was lost from one of the stars, the one that exploded, in the last 20 or 30,000 years before the explosion. Okay, so at the risk of misleading or a bait and switch on people who thought they were coming to hear a talk about leadership, let me show you this time series of images we've taken of the supernova 1987A. The connection is that I'm the principal investigator. That's a leadership position. Okay, here we go. Okay, so we've made this little time lapse. And you can see that the debris in the middle goes from being unresolved to being resolved. You can actually see the stuff moving out. Interestingly, that ring around is hit by the shock wave from the supernova, and it makes this beautiful ring of pearls around it that is places where the shock wave from the explosion is hitting the material that was lost from the star before the explosion. So I show this to you many times because it costs $1 million per picture, so we really ought to do it. But it's more than just a pretty picture. It's something that allows us to understand what that object is, how stars explode, and a little bit where we came from, because the chemical elements that are in your body, so the calcium that's in your teeth, the iron that's in your blood, the oxygen that you're breathing here today, all had their origin in stars, and one of the places where the heavy elements that stars make are broadcast into the gas between the stars to become the material for the next generation, including you, is in supernova explosions. So you should care about this. I, of course, care about it because in 31 years I've written 37 papers on supernova 1987A. So for me, it's been very important. But let me just say one thing again about how people work together to try to shape the future, and how people of today are trying to work together to make the future for astronomers and for science and for society in the future. And one of the things that we had always said, and it was in the decadal report that people in this room have worked on to help guide the development of astronomy in the US, is that it would be really great if we had super duper resolution. That means we could see really sharp images with the Hubble Space Telescope from space, with the CHANDRA X-ray satellite that's measuring X-rays, so not visible light, but much higher energy photons, and have a radio telescope on the ground that also had the same resolution and could see some of these same things. And so here, this image shows what that was all about. So we try to get together and have a planning process to figure out what to do, try to get the NASA and the NSF and now DOE to do the right things. And this picture shows you that we really got there for this particular object and of course for a wide range of objects where we're getting information, even though the supernova is 10 million times fainter than it was back in 1987, we're getting very good information from all of these tools that we can compare to one another and use to learn much more about the physical properties of the explosion. The X-rays are coming from that collision between the fast-moving stuff and the circumstellar ring, and you can see that they're out there making this thing look kind of purple. ALMA is a radio telescope, and the emission that you're seeing here is coming from stuff that is very cold. It's only a few hundred degrees Kelvin. It's molecules that form in the heart of this expanding cauldron of stuff. Okay, just one more thing about the supernova, and then I'll turn to the question of leadership in a turbulent age. Of course, in addition to this set of wonderful instruments, there have been smaller instruments, more specific ones, to study particular things about the universe. And one of them is a satellite called NuSTAR, which operates at high energies for X-rays or low energies for gamma rays, if you think of it that way. And this explosion that I described a minute ago is something where we believe the core of the star collapsed down to become a neutron star. We believe that because there's evidence that neutrinos would be, well, there's a theory that the neutrinos would be emitted, and there's evidence that they were detected on the Earth. That's what the distinguished physicists were discussing there on camera. And you heard Sterling Colgate say that he was hoping that there would be one, a supernova in the galaxy because there would be so many neutrinos, and he said he could taste it. This, of course, was the origin of the idea of neutrino flavor, which has turned out to be quite important. What I'm showing you here is a spectrum, so it shows at different energies. Here's 70 kilovolts, 80 kilovolts. The spectrum of supernova on 1987A, if you look at it long enough with this wonderful specialized satellite, shows these emission lines. This is the radioactive decay of the element titanium. Now, 30 years after this was formed in the first few seconds of the explosion. It's been decaying slowly because its lifetime is decades, but now that faster decaying radionuclides, which powered the supernova earlier, have decayed. Titanium is the main contributor to the energy input from radioactivity. This is good stuff, Stan. You should, you know. Gonna be in somebody's bones someday. That's right. That's right. It's gonna be in your hip someday. There's a joke. Okay. And just to say, this idea that you have a radioactive explosion and it makes some new elements in the explosion also works to explain the optical spectrum shown here. Okay, that's more than you want. Here's what you want. And of course, what we're trying, this production of new elements was set up in the first few seconds of the explosion. The distribution of those elements was set up in the first few seconds of the explosion, but now, 30 years later, we're getting a view of what happened. And so, you know, we're wondering whether the explosion might have looked something like this, or maybe it was more shredded like this with a bigger velocity distribution. And people are working hard to try to understand the physics of those explosions. Let me just say one more thing about science, and then I'll get to the politics. As I said, and you heard those people talking about the neutron star and the neutrinos, so people think that the signature of the forming neutron star was the neutrinos that we saw. That sounds like a very good story. So we've been looking to see if there might possibly be a dot in the middle, which would be the light coming from that neutron star. And all I can tell you is, if you look at this location, which is the place where the supernova explosion had its center, and you just make yourself a little game, you know, of a bunch of different dots of different brightness. You know, you can see it, you can see it, you would have seen it, you would have seen it, you would have seen it, yeah, here, I don't know, maybe somewhere. So somewhere in here is the limit of how bright that object would have to be for us to see it in our space telescope data from our most recent observations. And we don't see it. There may be good reasons for that. Dust formed in the supernova at these low temperatures I described earlier, and so maybe it's obscured by that. Or possibly it's something more interesting. Possibly the neutron star had stuff fall on it and it went over the cliff to become a black hole. Even then, you might expect to see some emission in the neighborhood. So I just want to say that when we think we know what's going on, and in the case of supernova 1987A, we think the most important thing we learned was that neutron stars really do form, and that's how the explosion takes place. We're still looking for the evidence to show us that that's really true. Seeing the titanium lines from the radioactivity was great because we believed that there was radioactivity making this thing going, but we needed evidence to be sure that it really was true, because after all, the human mind is a fallible thing, and without the data, you don't know for sure whether your story is right or not. This, however, is not the method that's being used most frequently in the national discourse, I would say. The use of evidence and facts to see what's right and to tell you how to act. So I would say in the old days, that is what I would call the standard model of reason, we'd say things like, well, you know, facts are pretty stubborn, doesn't matter who you are or what you think, you're stuck with the facts. And what we've heard in the last few months, and even before that, is that people's opinions are not always produced by rational thought based on the facts. You might think they were, but they're not. In fact, this is now regarded as a political statement by those Federalists, and that the people of the other parties don't believe it. Well, in fact, that sounds kind of silly, but if you look at how people think about climate change, it turns out that this view has become very politicized, so that if you ask people what your political affiliation is, and here the Pew Research Center has looked at conservative Republicans, moderate or liberal Republicans, I didn't know there were any, moderate Democrats, liberal Democrats, and then you ask them questions about, more or less fact, about whether climate change is occurring. What you can see here is that the sorting, where here the conservatives are shown in red and the liberals shown in blue, the sorting about what people think about what you might think was a factual question is the same as they're sorting along a political dimension. So what are the causes of climate change and so on. So here's a statement. Almost all climate scientists agree that human behavior is mostly responsible for climate change. And you see that among the conservative Republicans, only 13% of people agree with that. If you go all the way to the liberal Democrats, only 55% of the people agree with that. It's just the question is about whether climate scientists agree or not. So it's a curious thing, and there is a kind of attribution of motive too. Why do people say the things they do? Well, is it the best available scientific evidence? Well, people's view of that sorts the same way. Concern for the best interests of the public sorts the same way. The scientists' desire to advance their careers. I must say this is a defective question, because the scientists always want to advance their careers. So what's that got to do with it? Anyway, or scientists' own political leanings. So the point is there's been a tremendous erosion of trust and a tremendous change in how people view what you might think was more or less an objective question, whether the temperature has been changing and whether human beings have something to do with it, into a political thing. So, but before you get too smug about this, The Pew Trust also looked at people's opinions about genetically modified organisms, and some people, probably some people in this room, deal with people who think those are poisonous and they're really bad for you. There's no evidence for that. And vaccinations are something which in California has become kind of a contentious issue, whether vaccinations lead to autism. Turns out the scientific evidence is against that, but many people act based on their own opinion in that area. So this is a tough area for us all, where there's a kind of erosion of trust. And even skepticism has gotten a bad name, in my opinion. It seems to me it's a good thing to be a skeptic in a healthy way. That is to say, oh yeah, show me the evidence. And I've got to say there is at least one heartwarming story on this topic, and that's the story of Rich Muller. Rich Muller of Berkeley was the advisor to two people who have won the Nobel Prize, so he's got my vote. So anyway, and here he is doing something at an optics class or something. And as many of you will know, Rich Muller was very skeptical about whether the temperature data for the evidence on climate change was reliable. And he got money from the Koch brothers, which might make you think, oh no. But he looked into this question, and here's the op-ed he wrote for the New York Times a few years ago. It says, "The conversion of a climate change skeptic. Call me a converted skeptic. 3 years ago, I identified problems in previous climate studies that, in my mind, threw doubt on the very existence of global warming. Last year, I concluded that global warming was real and prior estimates of the rate of warming were correct. I'm now going a step further. Humans are almost entirely the cause." Okay. It took Rich some years to catch up with climate science, but nevertheless, the point of it, I think, is a good one. That it's one thing to be a skeptic and analyze the data for yourself, look at the evidence, and convince yourself. That's actually a good thing. The shorthand, though, is when people call themselves climate skeptics now, they mean, I don't believe the evidence, or there isn't any evidence. Okay, so we have come to this place where I think we have to worry about the public discourse and what scientists and even rational thought and facts have to do with things. I'm sorry, Jeannie, your answer was correct, but Kevin shouted his incorrect answer over yours, so he gets the points. Well, whether you find that offensive or not, I don't know, but anyway. So I thought it would probably be a good idea for me to go to the ultimate source of wisdom in the 21st century, and that is to Google facts matter. And I did, and I found that it's a website set up by the greater Cincinnati area. It turns out Don Osterbrock is from Cincinnati, so that is why I have brought this into the talk, about facts about the Cincinnati community. I guess it's supposed to persuade you to build a building there. Okay, so I treated this in kind of a lighthearted way. As you know, many of our colleagues are very worried about the government's attitude towards science, and I think we have good reason for it. One thing that's interesting, of course, is, and this came out quite strongly at the American Geophysical Union meeting, which was in San Francisco in December, and people are very worried about the accumulation of climate data and access to data, and we'll see how that all works out. Nevertheless, there was a kind of an emotional moment, which I'd like to show you, where Jerry Brown told the assembled geophysicists what he thought about the current state of affairs.
It'll be up to you as truth tellers, truth seekers, to mobilize all your efforts to fight back. And we have a good example. Big Tobacco was pretty powerful, but they lied and they came a cropper, not just with scientists, but with lawyers. And in California, we got plenty of lawyers. So we got the scientists, we got the lawyers, and we're ready to fight. We're ready to defend And California is no stranger to this fight. For a long time, we've been fighting efforts to reduce vehicle emissions, to improve our environment, and in recent years, we've taken even more aggressive steps. The California Vehicle Emission Standards became the national standards. California drove the United States. The Obama administration responded to the California Air Resources Board. That's how we got there. So a lot of people say, what the hell are you doing, Brown? You're not a country. Well, judged by measures of gross domestic product of over 2.2 trillion, we're the 5th or 6th largest economy in the world. And we got a lot of firepower. We got the scientists, we got the universities, we have the national labs, and we have the political clout and sophistication for the battle. And we will persevere. Have no doubt about that.
Okay, thank you, Jerry. Okay, so as you know, this is sort of crystallized into a question that many scientists and scientific organizations are having to face up to, where there is this idea that maybe we should resist what's going on at the national level. And here I show you a resistor button, which you can buy on Etsy for $3. It turns out it's only one of a kind, so maybe it's already gone. And there's a certain emotional appeal to that, and I thought it might be fun to talk about it a little bit here. So, as you know, there's a plan for a March for Science. It's going to be focused in Washington, but there'll be branches of it within commuting distance for all of you, and you might want to think where you stand on this. And so the idea is that you have the Earth with 3 electrons. That would be lithium, I guess. Anyway, you have some kind of symbol of science up there and some symbol of Washington, and that there would be a march on Washington, which is trying to capture that idea that Jerry Brown expressed so well of kind of defiance in the face of this threat to scientific thinking and scientific and science in the use of science in the government. So you could ask yourself about this question: is this something we should do, or is this something we should not do? And you can think of arguments on both sides, and I'm not telling you what to think. It seems like, on the one hand, Jerry Brown is saying something that appeals to a lot of us. It'd be great to stand up for science and say we really believe in this. It's important to society. And we want to support innovation and discovery. Science is the vehicle for all of that. There's the risk that the discussion might become like the one that I showed you there for climate science, but for all of science. That is, become politicized so that you could tell what people were going to say about this just from knowing how they voted. We've always tried to keep it so that the science itself was something that everybody could support, that's good for everybody in the country, and that it wasn't just the province of one political party or the other. So, you would worry that you might have the possibility of making all science as polarized as climate science. Well, so what are people doing? Many of us are members of the AAAS. Sandy and I were successive chairs, I think it is called, or whatever it's called, of Section D, which is the astronomy section of the AAAS. And it turned out it was not that interesting in a way. Our main job was to filter the proposals for talks at the big meeting. Okay, we did that. And to help people get elected to be fellows of the AAAS. And it turns out the principal requirement to be eligible to be elected was you had to subscribe to Science magazine for 6 years in a row. I believe it was 6 years. Anyway, just to say, it is the big umbrella organization, and it is the organization that has scientists of all kinds. And your own Gene Turner in the astronomy department here is a member at large of the leadership for the astronomy section. what we discovered by serving on this, in this role is that the AAAS doesn't pay any attention to the sections when it comes time for policy. They have a kind of another set of governing bodies for that. But Rush Holt, who was a congressman, who's a physicist turned congressman, so he's one of the few you've got, is now the head of the executive officer for the AAAS. And he has used this somewhat lukewarm formulation. He said, well, it'd be a terrible thing if they had this big March for Science and we didn't do it. We didn't participate. So the AAAS has decided to participate, but the level at which they're going to do it is still open for discussion. And so, you know, you might want to be part of that discussion. Okay, so you might say, well, all right, Mr. Useful and Polite, what are you going to do about it? And are you going to give us any advice? And the answer is, not exactly, but what I will do is give you a kind of flashback, which is, of course, in 1967, when I was 18 years old, I thought, wow, this war in Vietnam, very bad thing. We should march on Washington. And you know, it's a more serious thing than funding for science. But I found the picture of me in the Boston Globe from 1967. And it made me think that it's a good practice to try to remember how you thought about things when you were 18. I'm sure George Blumenthal does this all the time when he's trying to decide what to do here at the university. And here I am reading about the protest. I'm pretty sure this is the Washington Post, not the New York Times, because the Washington Post has comics. And we're reading about that before the March on Washington. Okay, well, that is what I really have to say to you. I am going to give you some advice, I guess. First of all, science itself is valuable. If that's the argument, then doing your science is an important thing. So although some people are caught up in the turbulence of this moment so much that they are spending nearly all their time on it, I think a good idea is to remember that the scientific work that you do is itself a valuable thing, so doing your science is a good thing. There's a tremendous amount of noise out there. That's a form of turbulence, I suppose, that all that rumbling that you hear, and concentrating on intellectual work is not easy in that climate. I myself have had some conversations with Kolmogorov. These have been reported to the FBI, and there's no problem with that. But I think there is a question about what you might like to do, and whether it's participating in a march or something associated with the march that's an educational activity. I think it's a good thing to make a practice of doing something and using at least a little slice of your time, think of like a tithe of your time, for public good. And that's my message for you today. I'm not telling you what to do. You'll notice that I used at least half my time to talk about the science itself, and it makes me think warmly. I'm very happy to have had this opportunity because it makes me think warmly of someone I knew and admired, Don Osterbrock. Thank you very much.
Well, it was a wide range of topics, so a great landscape here for questions. I'm going to start off with one, if I may. So I sort of wonder, people wonder, what's the use of astronomy? You know, it's not practical the way material science is or something like that. Right. So do you think that the daring nature of astronomy, the fact that we try to explain things very far away in space and very far back in time and claim some success, do you think that showers credibility on science as a whole?
Well, I hope so. You know, the idea that the Earth goes around the sun is widely attributed to have a big influence on intellectual history. And I think our current picture of a universe that has changed over time from a hot, dense Big Bang over 13.7 billion years, and we're probably right about the 13, and we might even be right about the 0.7, is something that is really extraordinary, where we've been able to take these faint clues and put together a coherent intellectual picture. It's not complete. We know that there's plenty more to do. If we had a 30-meter telescope at a really good site, we'd be able to do a lot more. But I think people like that adventure. It's an intellectual adventure. It's also a technological challenge. I talked about these instruments, the Space Telescope, the ALMA radio telescope, the CHANDRA X-ray Observatory. These things are at the frontier of technology, or they were when they were built. By giving ourselves really challenging problems that where the answers are so stimulating and so uplifting, I think astronomy has a especially good role in science. So, it sounds a little self-serving, but it's right.
But it's
right.
Exactly.
At least my opinion is that it's right.
Absolutely. Paul.
Yeah, I wanted to ask you a question about your last point
about
politicizing all science.
Yeah, I'm worried about it.
I'm a paleontologist, and my science has been legislated on, and school boards have decided whether or not they can teach it. The evolutionary biology. Yeah. And I also study climate change, and over the last 30 years, the same folks have come for that. And you all have time. You study time, and you believe the universe is old. And most of these folks don't believe the universe is old.
Right.
And so how safe do you think astronomy is from the same kind of forces that
well,
up evolutionary biology?
Yeah, that's good. That's good. Of course, there's certain schools of thought against which we've done pretty well. Astrology, we're holding our own, I would say, against them. And they still have a place in the newspaper, but there's also often a column that says, when Venus is setting and so on, so that's all right. I would say you raise an interesting question, that this kind of received wisdom approach to the physical world is something which is a problem for your fields, and I think it can be an increasing one for our own. There certainly are people who resist right at the beginning the idea of a kind of material beginning to the universe, and it's fair to say it's still a bit of a mystery, and so we shouldn't be too dogmatic. But on the other hand, the areas that we know about have increased, and the area of mystery has become smaller and better defined. So, that doesn't prove that we're sort of on the right track. But if your question is, what's the evolution of the universe, or how does the material universe change over time? I think we're on pretty solid ground, and we should be forthright about that. I think sophisticated people who are religious often think, well, I'm not too worried about that. You couldn't, for a real believer, you could not disprove or undermine their faith by an argument about the material world. So, the Pope has made that argument.
Yeah, do you have a rejoinder?
Well, it was more of a political question, because I've seen it happen twice.
Yeah.
And this is a field that relies on the public's largesse.
Oh, indeed we do.
To do its science. And if they come for you, what's the right political strategy? What is the right? What will the right strategy be if you see that same kind of resistance to your field begin to arise?
Well, there's a certain nugget of residual of people whom you're not going to persuade by evidence, and I think you do have to be modest about that. But I think making the case as broadly as we can, being inclusive and tolerant of a range of ways of understanding what the scientific story is telling us is probably a healthy thing. So I don't know the answer. It's a good question. We should worry about it a little bit. I think we have enjoyed tremendous public support, and we certainly have to keep our side of the bargain about telling people what we found and helping the best we can to make it part of a world where we use evidence and reason to solve the problems of the world. And that's that broader kind of use of your education that Sandy was alluding to right at the beginning. I've had students who have gone on in science and have done pretty well, but I've also had students who have veered off in other areas and have been very successful too, because for astronomy, being able to deal with large sets of ill-defined data where the question isn't so clear, turns out they're really good at high-speed trading and stuff like that. So there is a certain kind of market for that skill. I think more broadly, the ability to deal with uncertainty and the ability to deal with ill-posed problems is something that, at least in astronomy and maybe in many other fields, is something which is a real talent and a real strength that doing a higher degree in the field does build up. It is, in a way, though, the most wasteful way to make an investment banker, I would say. But nevertheless, it seems to work out in many cases.
Where's the evidence, Bob?
Oh yeah, you're right. So that $500,000 is lost in the noise
Yep.
by the time they're done.
That's right, if they're good.
If they're good. Yeah.
I don't know if you're familiar with some psychological studies that have been done about the way people decide what they believe. And it has a lot to do with the messenger and their identifying with the messenger and believing that the messenger holds their core values.
Yeah.
And that it affects you no matter where you fall in the political spectrum.
Right.
You're more likely to believe the messenger and what the messenger has to say despite any factual evidence that's presented based on your perception of that messenger representing your group and your values.
Yeah. Isn't it a shame we're dealing with people, you know? I mean, it's just, we're talking about human beings and how their brains work. We're trying to talk about objective reality out there. And, well, anyway, that's right. And so it's not just the political spectrum. It has to do with something about who you trust and something about the voice of the expert in society somehow becoming that suspect, you know? Trump would say elitist, you know, if you actually know what you're talking about. That's an elitist thought. So I think we're in an area where how people form their ideas and, you know, how you transmit them is tough. But I think many people can see most people don't know a scientist and they don't deal with scientists. And so I think things like real scientists, students included, please, being in touch with the public is a really healthy thing, because people can tell that you have the fire alight, that you really care about the ideas, you really want to tell the people that you're with. If you've ever been with a group of amateur astronomers, it's so much fun. But it is a rarefied kind of fun, and it doesn't touch everybody. And so it's probably not true of the big core of the population. Nevertheless, I don't think you should I don't think you should short circuit it. I think if you have the opportunity to do these things, it's a good thing to do.
I think I see a lot of questions here, actually, but it's getting a little bit late. I wonder if you would be willing to stay a little bit after and talk with people individually. If
Sure, I thought you were going to say, I thought you'd be willing to give shorter answers.
You can read
That's another approach.
You can read people's minds. Another talent.
Oh, yeah.
Why don't we take one more question? I'll let you choose.
There's somebody way in the back.
Oh, okay.
Okay, way in the back. Hi there. Hi, Bob. Oh, hi. Wearing red today? I wouldn't have been able to do this without my wife helping me. Oh, sorry, little joke there.
Matthews, wife of Bill Matthews and Mayor of Santa Cruz formerly. But I just want to your last point. We are organizing a March for Science here in Santa Cruz. It's a wonderful international effort in 360 communities counting so far. And I just want people to know about it. Science is wonderful. It affects every single aspect of our lives. And yeah, come a beautiful spring day. It's going to be April 22nd, which is Earth Day. Going to gather at Santa Cruz City Hall at 10 and march over to San Lorenzo Park to Earth Day and be there and stand up for science. And I am such a believer in building community and building relationships. And you know, it doesn't always lead to an earth-shaking discovery, but it's part of the picture. So, thank you.
Thank you, Mayor Matthews.
That's great. That's great. So I want to thank you again, Bob, for obviously a very stimulating experience. And I think I personally have had a lot of ideas about further events and discussions that we might have as a result of comments made by you and others here. So I want to thank you very, very much.
Thank you so much.